Any more questions for Dorothy? Or any of the speakers? So we are right on time, 1:10 p.m. Eastern, to move on to the next session. Chaired by
Good job, Vijay. Excellent timing.
And hello, everyone. This is Ed Rappaport. I'm at the National Hurricane Center. Our agenda now has a change of direction, and as has become our custom after hearing from about the programmatic parts of the HFIP program, we moved to the operational side, and the first session is about and largely from the tropical cyclone forecast centers. And in terms of the mechanics, I'm a co-chair for the session, and Brian Zachry is also a co-chair. And what we'll do is he serves as my backup in case there's some kind of technical issue for the first part of the session before the break, and then we'll reverse those roles after the break. Regarding the talks themselves, we have each topic has been given 20 minutes, and we asked that the speaker use up to about 2/3 of that for their talk, and that would leave some time for Q&A at the end. So I think what I'll do is I'll just monitor, and if we get close to around 15 minutes and the speaker is still going, I'll let them know. And first up on our list, and again, the overall topic is forecaster needs and activities supporting operations. And John Cangialosi from NHC is our first speaker, and we'll be talking about current forecast capabilities, NHC verification. John, you ready?
I am here. Thanks, Ed. I just want to say hi to everybody. I hope you're doing well out there given the circumstances. And for those of you that I haven't met, again, I'm John Cangialosi, one of the senior hurricane specialists at NHC. Since my daughter's also doing school virtually, I am going to turn off my camera to give myself a better shot. I'm not being antisocial, just hoping for a stable internet connection here. All right, now, obviously, what I'm really going to do is, in a nutshell, just kind of give you the report card for the Hurricane Center in terms of track, intensity, and genesis for the 2020 season. So, Ed, if you can go to the next slide. Let's start with the Atlantic. Now, I first want to point your attention to the chart on the left and focus first on the blue line. Notice that the track errors start off pretty low for the short lead times, both at 12 and 24 hours. And if you glance at the table on the right, you'll see that our 24-hour track error is about 36 nautical miles. But like every year, our track error increases with forecast time and ends up around 190 nautical miles by the 5-day forecast point. And we see that general evolution of the track error increasing with time just about every year. On the green line, you'll see our intensity errors, and they behave pretty differently. They go up for the first 2 to maybe 3 days and then sort of flatten out around 11, 12, 13 knots from day 2 to day 5. If you look at the table on the right, you will notice that there are no numbers that are shaded in green, indicating that, unfortunately, no records for accuracy were broken by NHC in 2020 in the Atlantic Basin. Now, if you go to the next slide, Ed, I want to show you how busy it was this year. Of course, there's many ways to gauge how busy a season is. And the best way for us to gauge it at NHC is an index for what I call forecaster fatigue. And talking to my colleagues over the past few days, we're all just frankly exhausted. We're very, very exhausted. Part of the reason we're very exhausted is so far up to today, we have issued 601 forecasts in the Atlantic Basin. Now, if that sounds like a big number, it is, and you can see 2020 sticking out there like a big spike. In fact, it's the second busiest year for this metric over the last 30, only below 2005, where about 640 forecasts were issued, and way above what we normally do. On average, the average of that data set you're looking at is close to 320. So very, very busy in terms of many different metrics for the season. All right, Ed, if you go to the next slide. I'm sure many of you have seen this chart or something that looks just like it. And I want to show you where 2020 sort of fits into the overall. And yes, Frank, Max did retire after 2005. Maybe Ed's going to retire after 2020. I don't know. We'll have to ask him. All right, so let's take a look at where 2020 sort of fits in to the overall large-scale track error trends. Now, if you take a big picture look, something we've always communicated at NHC and amongst this community is that science and technology has helped build a tremendous success story. A success story of dramatically dropping track errors over the past few decades. And you can see it in this chart, whatever forecast period you look at, or if you glance at them all by looking at the linear track error trends. But the bad news is, if you just look at the last handful of years, direct your attention from maybe 2016 to 2020, you'll notice that the track errors have been much flatter. I'm not calling a plateau here, but I am suggesting that there's a little indication of that by looking at track errors, that the errors from the Hurricane Center anyway have changed little in the last handful of years. Now, we can't just look at error. Let's also repackage this data and look at it in skill space. And Ed, if you go to the next slide, you'll see it there. And it basically tells really the same evolution. That the track skill was going up nicely through the 90s, through the 2000s, and about halfway through the 2010s. But again, over the last handful of years, NHC track error and track skill has been more or less flat. Now, I don't know if this is temporary or what's going to happen from here, but at least that's what the data suggests for now. So if you go to the next slide, let's look at how some of the models have fared in 2020. Now, this is in skill space as well. Of course, I should have mentioned skill is against the climatology and persistence model, or CLIPPER. And when you look at things in skill space, I'm sure you know the higher the line, the more skillful or more accurate the prediction from any of these models that I'm showing you here. Now, if you take a look at the black line, that's the Hurricane Center's skill for 2020 in the Atlantic. And you'll notice that it's way up near the top where it usually is, showing you that it's very skillful and close to the best performing models, which are almost always the consensus models. In this case, HICA is in pink, way up near the top. TVCA, our simple multi-model consensus, in orange, and the Florida State Super Ensemble in maroon, all very good performers, and NHC is basically near those models. Now let's look at the individual models. The best individual model in 2020 in the Atlantic is the GFS. Now, if I say that surprisingly, that's because I was surprised. It's been a while since the GFS has been the best model in the Atlantic. The European has had a crazy streak in the Atlantic Basin of being the best track model, but the GFS was clearly the winner in 2020. Sticking out there, it's that blue line with the highest skill from 36 to 72 hours. And if you average the skill at all the time periods, it's the best model, hands down. Now, second place sort of goes to sort of a group of models. It's really hard to call. The GFS Ensemble mean, we call it AMI. It's in that light blue cyan line. The European EMXI, also in a light blue line. HMON in green, and COAMPS TC in brown, all kind of clustered in there for second place. Below that, I would call them just okay performers for 2020, is the HWRF in pink. The UK Met, which was a really disappointment from our standpoint this year, because that model was really good the last few years, but not so great in 2020 in the Atlantic, and it's down near the Canadian also that year. And the only model that's truly out of the pack is the NavGem, which is shown here in red. All right, Ed, if you go to the next slide. All right, let's take a look at intensity. How has that been behaving? Now, if you take a look at the 2020 errors first, you'll notice that the red line went up a little bit. That's our 24-hour mark. The green line also went up a little bit. That's the 48-hour mark. But then the other lines went down a little bit from 2019. That's 72 to 120 hours. And if you take a broader look, you'll see, first of all, you'll see a lot of noise. But if you look at the linear trends, you'll notice that most of them are pointing downward, an indication that we are making progress with our intensity forecasting. They're gradually, slowly, and maybe not so steadily getting better, which I think is a good thing. And it's something the Hurricane Center wrote up in a journal article just a month or two ago in Weather and Forecasting. So making some gains when looking at errors in the Atlantic. And if you go to the next slide, we'll look at it in skill space. And it basically tells you the same overall story, that the intensity errors are gradually going up if you sort of filter through a lot of year-to-year variability. All right, and if you go to the next one, let's look at the intensity guidance in 2020 for the Atlantic Basin. Now, one of the things I'll say about intensity forecasting is when it comes to track forecasting, a lot of the forecasters take this approach. We try to sort of pick what we think is the best model. That's really a lot of the approach. I mean, we do a lot of science behind it, but that's sort of the end-all, be-all, is to try to get on the right side of the guidance. But when it comes to intensity forecasting, there's a lot more forecaster input that goes in. And I like to say that this is where the Hurricane Center sort of makes its money, so to speak. And if you look at the skill lines here, you'll notice and you'll sort of see that overall. The black line is from NHC, and you'll see it's, again, at the top end of the curve, but actually even a little bit above some of the consensus models. A very, very good performance overall. And if you're surprised, our skill looks like that most years. Now, we're generally closest to the consensus states, just like for track, specifically HICA, IVCN, and FSSC wasn't as good here. You can see the maroon line sort of trailing with forecast time. Now, the best overall individual model for intensity in 2020, that goes to the HWRF. And that's, the HWRF model, I'll just say this, when the HWRF shows something, we pay attention to it. That has become a very useful model for us at NHC. Again, the best model in 2020, just like it was for the past few years for intensity prediction. The COAMPS TC, which is in brown, the HMON, which is in green, are skillful, not bad, but they're not the HWRF. The SHIPS and LGEM, they're in red and purple in this case. And I'm sorry, I know there's a lot of lines. I feel like I want to point to these things to show you. But SHIPS and LGEM are sort of fair performers. They're gradually being used less and less in ops, I would say. And one thing that's interesting to me is that the global models are starting to become somewhat competitive. In particular, the GFS, which is in blue there, you can see it's kind of in the pack now. The European, maybe not so much. That's in the light blue color. All right, Ed, if you go to the next slide. Let's take a look at Genesis for the Atlantic. And to build up a sample, I looked at 3 years instead of just 2020. And in this case, if you look at the 3 years, you'll notice a few things. The red line is for 2 days verification. The blue line's 5 days, and the purple line is internally only 7-day verification. They all look basically the same. There's a little bit of a low bias for some of the low probabilities, like 10, 20, 30%. There's also a little bit of a low bias for some of the high probabilities, like 80 and 90%. And I kind of don't love the way the middle looks because it doesn't seem greatly calibrated. But I would say that this is not great, but certainly not a terrible result. Sort of just needs a little improvement. All right, if you go to the next slide, Ed. All right, we'll get to the basin that I know you're all waiting for, the East Pacific. Now, the good news for the East Pacific is obviously when the Atlantic is busy, most years the East Pacific's really quiet, and that's what we got in 2020, which was certainly pleasant for us. And if you look at the East Pacific verification, first focus on the blue line like before, you'll notice that the track errors, likewise to the Atlantic, start off low. The 24-hour error is around 36 miles, which was identical to the Atlantic. But the error increases less with forecast time, so that when we got to 5 days in this case, it was about 50 miles lower than the Atlantic, around 145 nautical miles. For intensity, the errors were a little larger than the Atlantic. You could see they increase a little more sharply through day 3 and then flatten out after that, somewhere between 16 and 18 knots. Now, if you look at the table, you will notice in this case, there are a few numbers shaded in green here in the East Pacific. Those are all-time records that were broken for intensity forecasting this year for some of the short lead times. No records broken for track accuracy. Okay, Ed, if you go to the next slide. I mentioned the East Pacific was quiet. Let me show you how quiet. It was the quietest year in a decade, which was nice to see. 243 forecasts issued so far. We got one trying in the East Pacific now, which was, again, the quietest year since 2010, and a nice pleasant change compared to what we had in the Atlantic. Though at full discretion, I'd much rather have a busier EastPac year and a quieter Atlantic year. But again, we don't get to choose that. All right, Ed, if you go to the next slide. Let's look at the East Pacific track error trends. And I want to show you that we really see the same evolution as we saw, and I just showed you in the Atlantic. Now, if you take a wide view, you see those tremendous gains that we know and talk about all the time. Our track errors have been steadily improving over the decades in the long term. But again, if you just look at the last handful of years, maybe in this case 2016 again, you'll notice that the trends would be much flatter over the last handful of years. And I'm not going to show you skill in this basin, but it still points to that same sort of plateauing that we saw in the Atlantic. All right, next slide. Here's the track guidance for the East Pacific. The Hurricane Center track skill is in black. And you can see that, I got a comment from James. Yeah, James, you got to come back. I think that's the answer. The black line, you can see it's up near the top. That's the Hurricane Center skill right there. Generally close to the consensus aids, just like before in the Atlantic near TVCE, HICA, and the Florida State Super Ensemble, all pretty solid performers also in the East Pacific. HMON is in green. You know, one of the good, interesting things about the East Pacific track, just like, you know, the Atlantic, I told you the GFS was the track winner. I don't think there really is a winner for the East Pacific track. You have different models sort of winning at different forecast times. For the short lead times, the HMON and the UK Met had the highest skill at 12 and 24 hours. For the other times, the European had the highest skill from 36 to 60 hours and also at 5 days. And then at days 3 and 4, the GFS had the highest skill. So no real winner. But what we do know is that the HWRF and the Canadian were generally less good. They're shown in pink and yellow. And like the Atlantic, the NavGem is generally the least useful model to us at the Hurricane Center. All right, next slide, Ed. Here's the intensity error trends in the East Pacific. And we did have a nice downward trend here off the 2019 bump up that we saw last year. And you can see sort of nice downward looking trend lines here in the long term, especially at 48 hours and beyond. The same evolution is shown in skill space. So again, you definitely could acknowledge that we're making some gains here. Thanks, Ed. All right, if you go to the next slide, only got a couple left. Here's the intensity guidance in the East Pacific. The Hurricane Center forecast, again, in black, up near the top end of the curve early. But what you'll notice when you look at this chart is the skill sort of tanked late. At 96 and 120 hours, most of the models and NHC were in negative territory, which means in this case that the decay Schiffer errors, or climatology and persistence, said that the basin should have been very predictable at days 4 and day 5, but the models didn't seem to think that. But that is sort of responsible about why there's so much modeling and NHC in negative territory. The best model is one that I know almost nothing about. It's NNIC, which is, you're gonna have to ask Mark about that. That's another consensus aid that he worked up experimentally, did really well in the East Pacific, at least through day 4. The HWRF in pink was a really strong performer here as well, all the way through 96 hours, but then the HWRF sort of tanked later. Chips and LGEM, fair performers. They're red and purple, but no skill late. And GFS, maybe somewhat competitive at some periods, but the European really not so much. And then the last slide, Ed, I think I have, talks about Genesis in the East Pacific. Now, just like I showed you for the Atlantic, this is a 3-year sample. The red is day 2. The blue is day 5, and the purple is day 7. Take a look at those results. James, this is something that has improved after you left. Well, credit to you retiring on this one anyway. So this is a very skillful, very reliable Genesis forecast in the East Pacific. Very little bias and something that looks really well calibrated. So just significant improvements in Genesis. And then the last slide there, Ed, is just to sort of wrap up and give some highlights. Again, busy year in the Atlantic. No records for accuracy broken in 2020 in that basin. Again, some signs of track error and skill leveling off in both basins. Slow, maybe not so steady progress for intensity forecasting. Good year for the GFS in the Atlantic for track for a change, a really good year. And for intensity, same old story, HWRF the best model again. Nice quiet year in the East Pacific. We did break some records there. No clear winner for track really or intensity in the East Pacific. And again, just showed you the really stellar Genesis forecast for the East Pacific, but could use some improvement in the Atlantic. So that's all I have. Thank you.
Yeah, thank you, John. We have just a couple minutes left. There are a couple questions and a couple comments in the chat. Maybe John, you could try to address them. The first one, I believe from Scott, asks about the 7-day verification. If you have any comments, I know you had one remark about that, but maybe if you have a moment to talk about what we're doing at NHC and how those forecasts look.
Yeah, so I haven't looked at the details, but we are doing day 6 and 7 track intensity forecasting. And for track, they look about what you'd expect. They're going up at a pretty similar pace of around 30 or 40 nautical miles per day at day 6 and 7. So you could almost sort of extrapolate, and that would get you pretty close to that answer. And for intensity, our day 6 and 7 intensity errors are more or less the same as day 5. So I haven't looked at the details for 2020, but I imagine there'll be a good sample. So we'll look into that more certainly as we get toward the off season. Okay,
thank you. I think we have one more topic that was actually addressed by a couple people. Stan Goldenberg asks or says, with the intensity trends, would be interesting to somehow rank the years by number of cycles with rapid intensification occurring. There was also a comment by Dorothy asking whether storms are getting more challenging to forecast. I think the latter one you can address with skill, with your skill diagrams, but maybe if you have any thoughts on that and perhaps ranking the years by numbers of cycles of RI.
Yeah, that's sort of interesting. You're right, Ed. We can sort of do the challenging stuff by skill, which is something we kind of saw. I showed you very briefly. I haven't ranked them by RI. I mean, that's somewhat incorporated in the skill because RI is always challenging, but that is a good project. I'll try to get that ready for the verification report this spring. I don't really have anything to go off of at this current time.
Okay, thank you, John. There's a fair amount of back and forth on the chat. Encourage folks to continue. Maybe, John, when you have a chance, you'll take a look at that too. I know Mike has weighed in from NHC and a few others have as well. Good discussion there, but we probably should move on to our next talk at this point. So thank you again, John. And also thanks, by the way, to Paul, who's helping out, at least at the beginning here, with moving the slides forward at the request of the speaker. So next up is going to be Mike Brennan, again from NHC. He's talk is with was developed as well by Eric Blake, and the topic is NHC analysis and forecasting challenges from this year. So I think Mike's the one going to be giving it. Go ahead.
Yeah, thanks, Ed. Yeah, good afternoon, everybody. I'll first sort of preface this by saying, we haven't had a lot of time to distill too many deep thoughts about the 2020 season yet, since it really hasn't slowed down very much. So this is sort of a preliminary look at some things we were able to recall from off the top of our heads and some trends that we might have noticed. So as we go on to the next slide, I'll just note that 2020. I was talking about this earlier today with somebody else. It's a season in which the extreme almost became commonplace. We had a tremendously active season, as John talked about, in terms of the number of forecasts. We've now issued over 630 advisories in the Atlantic this year, with 30 named storms, 13 hurricanes, 6 major hurricanes. ACE is over 180 and still ticking up on the meter with Iota. We had 14 systems that required the issuance of watches and warnings on the first advisory, which calls into calls to highlight the need for sort of improved early in the TC life cycle or even pre-Genesis forecast. The Pacific was relatively quiet this year, although we only had 4 hurricanes. 3 of them became major hurricanes. We may be having another system forming in the East Pacific at the moment. Move on to the next slide. Getting into impacts, 12 U.S. landfalls, which was a record this year, 6 tropical storm landfalls in the U.S., 6 hurricane landfalls, including Laura, which was a major hurricane. Also, Arthur was a tropical storm that had impacts in North Carolina, even though it did not make landfall. 5 landfalls in the state of Louisiana, 8 landfalls along the Gulf Coast, 13 landfalls in international areas, including the 2 Category 4 landfalls in Nicaragua, just 2 weeks and 15 miles apart with Eta and Iota. And Dan Brown and I were trying to think about all the countries we coordinated with in the Atlantic, and I think it was everybody this year. I don't think everyone from Portugal to the Azores to Canada to Bermuda to everybody in the Caribbean. I think there was a fair amount of activity that affected just about everyone in the basin. And if we go on to the next slide, another interesting way to look at it is this graphic that the WFO and Corpus Christi put together that shows the issuance of tropical cyclone watches and warnings combined through the entire Atlantic hurricane season up to the couple of days ago. And you can see that basically the entire U.S. coastline from Texas to Maine had some type of tropical storm, hurricane, or storm surge watch warning in effect for it, including some areas that extended pretty far inland with some pretty impactful storms going back to Isaias and Zeta and Laura. And that includes Puerto Rico and the U.S. Virgin Islands. And some pretty stunning facts here that we had hurricane warnings in effect for the Atlantic U.S. coastline for almost 16 days this year, and some type of coastal watch or warning in effect for the state of Louisiana for almost 20 days this hurricane season. So just a tremendous onslaught of activity that, especially in the western part of the basin, that ended up being very impactful. On to the next slide. We'll now get into some of the issues that we noticed this year in terms of just start looking at Genesis verification. This is from the models, and this is was provided by Dan Halperin at Embry-Riddle. This is their reliability diagram for the 48-hour consensus verification for the Genesis probabilities that they produce based on the global model guidance. And similar to what John noted, you'll see at 48 hours this sort of low bias in the Genesis forecast from the models this season, especially at these sort of 30 to 50% probabilities. We were seeing systems develop 60, 70, 80% of the time when the Genesis probabilities were 30 or 40%. And then just sort of a real inability to distinguish what was going to form from when the Genesis probabilities ranging from 40 up to almost 80%. There was sort of a lack of skill there, a lack of reliability and ability to distill what was going to form from what wasn't. And that's, I think, overall our subjective impression of the models this year for Genesis was that they weren't very good. Certainly not, it took a step back from last year, at least from our sort of internal discussions about it. If you look at the next slide, we'll look at the 5-day Genesis verification. A little better, pretty reliable, although there's a low bias, excuse me, a high bias for probabilities up above 80, 90, 100%, where it's only about 70 to 80% of those systems developing, which is sort of an interesting trend, despite the fact that the probabilities were pretty well calibrated for the other forecast probability numbers for the models for 5 days. Go on to the next slide. We'll notice that this is a map that Dan put together showing the locations of the false alarms that we dealt with this year. And there were numerous false alarms this season. The color of the X's actually indicates the Genesis probability. And here's some of those systems that resulted in that high bias in the Genesis probability. You see some 70s and 80s and 90s out here in the MDR, where the models were very confident that a system was going to go on and develop, and did not happen this year, especially in this region between 20 and 40 west. Fair smattering of false alarms, but with generally lower Genesis probabilities in the western part of the basin. Moving on to the next slide, we'll look here at just some Genesis forecasts that were problematic. This is what the tropical depression that became Hurricane Laura. This is at 0Z on August 20th with a 30-knot depression, 1,008 millibars. You can look at the 5-day forecast from the GFS. Really has very little indication of a tropical cyclone here at 5 days out here in the Atlantic MDR. If you go on to the next slide, you can see that the forecast, even 24 hours out, wasn't much better. It really had no reflection of what looked like a tropical cyclone in the model field. So sort of a sharpening trough, but not really much in the way of a closed low. Moving on to the next slide, we'll take a look at NANA, which was another model sort of forecast Genesis bust, a system developing in the Caribbean. This was on September 1st. It was actually formed as a tropical storm at 6Z, 1,006 millibars. You look at the Europeans' 30-hour forecast, very little signal of anything that looks like a tropical cyclone there in the sea level pressure or surface wind field. Moving on to the next one, which was Zeta, again, a Western Caribbean system. Later in the season, late October, here's the GFS 5-day forecast, really no indication of anything there in the model. And if you move on to the next slide, something at 48 hours out, really no indication of a system as well either. So some challenges there in terms of Genesis. Move on to the next slide. We'll talk about rapid intensity changes. This is just the best track intensity of a couple of storms that sort of went through some of these rather wild undulations in intensity that are difficult to observe, even much less predict. We had Sally go up 30 knots in 12 hours, come down 10 knots in another 12 hours, and then go back up 20 knots in another 12 hours after that. Something even more extreme on the next slide, if you look at Delta, where Delta increased in probability by 90 knots, or excuse me, increased in intensity by 90 knots in 36 hours, followed by a 45 knot decrease in 24 hours, and then a 30 knot increase in 30 hours. So again, these sort of almost step function in intensity changes that were pretty challenging to even observe and sort of work our way through operationally, and then try to make sense of in terms of how to adjust the forecast. On to the next slide. We had 9 Atlantic tropical cyclones that underwent rapid intensification this year. That was a big theme this year, and unfortunately, many of them underwent RI within the watch warning time frame, leading right up to landfall. You can see I've listed out the largest 24-hour intensity change based on the preliminary best tracks so far. You can see they range from 30 knots in Hannah to 40 knots in Laura to 20 knots in 12 hours in Sally to 65 knots in Delta, and then here Eta and Iota here late in the season both intensified 70 knots in 24 hours. So really extreme levels of rapid intensification, even by that definition. If you look at the next slide, put together something that was interesting, and there were some questions about intensity guidance, and John showed a little bit of the intensity verification. One thing that we noticed this year was just sort of inconsistency in the intensity model forecast, even for some of these rapidly strengthening systems. This is actually the late model peak intensity for Laura. So I'm not looking at anything that was interpolated. I just looked through the ADEX and picked out the highest intensity forecast that I could find anywhere in the forecast itself. So we're not looking at timing or anything like that. Just how strong did the HWRF, HMON, and COAMPS TC think Laura was going to get? Laura's peak intensity ended up being at about 130 knots. It was out here off the end of this chart at around 6Z on the 27th of September. I'll note, early on, you can see here on the 23rd and 24th, there were some pretty robust intensity forecasts, especially from HWRF showing something in the 130 to 140 range, HMON showing something 110 to 120 knots. But interestingly enough, when you get to this watch warning time frame, we issued the storm surge and hurricane warnings at 15Z on the 25th. In this period of time from 0Z on the 25th to 18Z on the 25th, the HMON and HWRF both sort of stepped back on their peak intensity forecast, showing 100 to 110, 115 knots. And then they sort of picked up again later on. So there was this sort of a valley in the intensity ability of the regional models, at least, to show the proper peak intensity of Laura sort of right at that watch warning time frame, which was a challenge. And I haven't had time to dig into this or what the reasons might be. There was land involved. There were some other issues that might have been involved as well. But and I saw there was a question in the chat earlier about the performance of the HWRF when there's TDR data in there. And while it seems to be pretty good, we're almost seeing different error characteristics of the model based on whether that intercore data is available. And so it's difficult for forecasters to really get a handle on when the forecaster should be given a lot of weight and when they shouldn't be, because again, you're seeing inconsistencies from cycle to cycle that could have things to do, I think Jason just mentioned, with data assimilation failures, things like that, if you're going to go out on the limb as a human forecaster and try to forecast something that's kind of at the edge of the distribution or something that's kind of extreme, you really want to see that consistent model guidance from cycle to cycle to give you the confidence to do it. And if you don't see that, then it's going to be hard to really push it that far. Moving on to the next slide. Here's just a forecast for IOTA. Here's just from a couple of days ago. We had a 70 knot increase in 24 hours. Here's the best track. All the intensity guidance showed a lot of strengthening. Unfortunately, it was a 30 to 40 knot increase in 36 hours rather than a 70 knot increase in 24 hours. So again, there is skill. There are signs in the model guidance that these quick intensification events are going to happen. But the challenge is it's often not fast enough, and we're often not able to truly capture the rate of intensification that we actually see. Moving on to the next slide. Again, this is something I thought about with intensity guidance skill, and this is somewhat different than what John presented. This is for the Atlantic, but this is for forecasts that verified when watches or warnings were in effect. So these are forecasts that verified either near or over land. And one thing that's pretty interesting here is that you'll notice that the HWRF skill drops down to just very low levels of skill by the time you get to 72 hours. And that could be due to the fact that the track forecasts from the HWRF have not been very good. Near land, that's exacts a pretty punishing penalty on the intensity forecast. If you have a system moving inland too fast or too slow, deterministic intensity forecast at a certain time is going to be punished pretty severely. But again, the error characteristics for the models are not all the same. The basin-wide statistics may not really show the whole story, especially in a season where you have a lot of RI near land, a lot of intense storms near land itself. So again, just something to throw out there for thought. Moving on to the last couple of slides, some track forecast challenges. Marco and its interaction with Laura was an especially challenging period. We had 2 storms potentially interacting in the Gulf of Mexico. This is the track model guidance from the 21st to the 23rd of August for Marco, and you can see it's generally all over the place from northern Mexico over to coastal Alabama. There was huge uncertainty in Marco's track, and that was related to the intensity of the storm and how deep the storm was going to be. And Marco ended up getting sheared off and didn't really interact very much with Laura in the end. But there was a lot of uncertainty there. Moving on to the next slide, we had some challenges with Sally. We had this sort of ever-shifting increase or ever-shifting rightward trend in the model guidance from cycle to cycle, where we had forecast originally in the watch warning time frame, having the system making landfall in Louisiana, shifting all the way over to making landfall east of Mobile Bay in extreme southeastern Alabama, and into having significant impacts in the western Florida Panhandle. So that was a very challenging forecast, very challenging hazards to message there. Moving on to the next slide, we had some challenges with Laura. We had some sort of poorly timed model trends that were not in the right direction leading up to landfall of Laura. We had a significant westward shift of the ECMWF ensemble mean 2 to 3 days before Laura's landfall. You can see these models plotted here that shifted the track significantly over toward the Houston metro area. Certainly caused a lot of angst and concern in the community, not just the meteorological community, but the emergency management community. And if you go to the next slide, you'll see that trend was there to the left as well in the deterministic ECMWF. Thankfully, our forecast sort of hedged and didn't make a big adjustment in that direction. Ended up being much closer to where Laura ended up making landfall. So move on to the next slide. Just one last thing to wrap up with. The trend, one of the trends that we've seen for many years now is the regional model track skill relative to the GFS. You see both the HWRF and the HMON have significant 5 to 10% or even a little more for HWRF skill loss for track compared to the GFS, especially in that 48 to 96 hour time frame. And again, that plays havoc with some of the intensity guidance that we get from these models. When there's some of your better models for intensity, but if they're not getting the track right, again, land interaction can really make that a complicated thing to incorporate into the forecast. So I think that's it. Last slide is just sort of, we had a lot of challenges. We need a lot more time to synthesize the issues that we've had this season. I'll just add that 2020 had a lot of challenges in terms of the activity, but also in terms of COVID and remote operations and staffing and even getting aircraft reconnaissance tasked and the ability to sample and observe these storms. It really took a Herculean effort from the entire community to pull off the quality of the forecast and the warnings and the life safety information we were able to provide this season. So again, welcome any questions or comments.
Yeah, thanks, Mike, for all of that. Certainly a lot of challenges, and I think we all concur with you on the kudos to all who were involved in the operations this year. Very challenging for a number of aspects beyond simply the forecasting. There's a lot of provocative discussion in the chat. We don't have a lot of time, but maybe we'll hit the first couple. Let's see here. There's one here from we'll start with Pete Black. He had the first one. So the tracks for 2020 seem to cluster along 2 main paths into the Gulf or up through the middle of the North Atlantic. Do shifts in long wave pattern account for this? I don't know if you have any thoughts on that yet.
No, we haven't really had a chance to take a look at any sort of meaningful way at that yet. But some of it had to do with a lot of genesis near or in the Gulf itself, and just the pattern that was in place at the time.
Okay, one more here. Question about why the 120-hour forecast of Genesis is more reliable than the 48-hour.
I think it's probably timing. If you have a longer window in which the genesis can occur, it's a little more forgiving. The 48 hours is kind of tough because if the system forms 54 or 60 hours later, it doesn't. You don't get a. It doesn't count for verifying that particular forecast.
Okay. Rob asks, was 2020 a record for the total number of Atlantic TCs that underwent RI?
I don't know off the top of my head. It's got to be up there, but I'm not sure.
Yeah.
Maybe
Okay.
James. I don't know if James is going to talk about that a little bit in his presentation, or if there's anybody else that wants to chime in on that.
Okay.
This is,
Silence
yeah,
so
this is
far.
more, this is more Spender GFDL, Mike. I have a question. I'm a little disturbed. The GFS for the Genesis did so poorly, and some of our retrospective testing of the GFS before it became operational at GFDL, we saw such an encouraging Genesis skill. I'm kind of curious. First of all, did it do better last year? And is the para GFS? Have you looked at that, whether it's doing better for Genesis? Because it seems to be more aggressive. I've seen that.
Yeah, the new GFS has a higher POD, but also a fair higher number of false alarms. So that's what we're going to be faced with next year. So that's going to present a different set of challenges, perhaps. But our sense was, I think, internally, and anybody else in HSU can chime in, that the GFS was not as good for Genesis this year, even though it was the same model. It could have been just the nature of the systems this year were different. But it was a challenging year for Genesis forecast, especially even for some of the more impactful systems.
Yeah, that's what I sort of thought, because I thought it did pretty decently last year. So maybe there's an anomalous year that it did so bad.
Or so
Morris,
good last year.
Morris, this is Eric. I think that GFS was kind of the best of a bad bunch. This is a hard Genesis year for some reason. The European had so many Genesis fails this hurricane season. But it was bad, but it might have been the best of a pretty sorry bunch of Genesis cases.
Yeah. Of course, they changed the physics quite a bit in the ECMWF, and I was wondering if that had some impact on the Genesis. But as you said, it just may be a very difficult year for Genesis.
The track was quite poor, too, as well, from the European. That was one of the takeaways from the verification talk.
Mm-hmm.
Okay, thank you both, Morris and Eric, for your comments, input here. And Mike, thank you again. There's quite a bit of discussion in the chat about what kind of observations might be useful to have or increase. Maybe that, we don't have time for that now, but maybe some of that will come up during the discussion of the models themselves and the challenges that the modelers had and the models had. Perhaps for you folks, you might want to take a look at what has been asked here, and if you can address those questions when it comes up, when you have your talks, or maybe during those talks. So thanks again, Mike. Our next topic is verification of rapid intensification metrics in 2020. I guess we don't have a dynamic duo, we've got a trinamic trio. James Franklin, Mark Demaria, and Matt Onderlinde are listed. I think, James, you're up first, is that right?
Yeah, I'm giving the entire talk.
Okay, thank you.
But yes, acknowledge my co-authors, Matt and Mark. Go to the next slide, please. Just by way of review, we have a goal, an HFIP goal, to reduce the intensity forecast guidance errors by 50% for RI events. We defined a baseline, which was to look at the mean absolute error of the IVCN consensus. The baseline was calculated from 2015 to 2017. For the Atlantic and East Pacific combined, we did that because the number of cases is relatively small. And it would be evaluated at only those times when RI was either ongoing or forecast by the model in question or any of the models making up the consensus.
So James, this is Ed. There was a question about whether you could speak a little more loudly.
Okay.
Volume up a little bit or closer to the mic, I guess.
Okay. Is this better, I hope? So let's go on to the next slide, please. So with that as the definition of the baseline, the solid green line in the left figure shows what the baseline errors are. They go up very quickly. So by 24 hours, we're talking about a baseline error of 26 knots, going up above 30 knots. And so you can see 50% of that, which is the target, gets you down into the mid-teens for our target. Next slide, please. So the results that I'm going to show today all are done through the first landfall of Hurricane Eta, and I hasten to add not one iota more than that. Looking at the results for the consensus, so the members that make that up are shown there: Decay Ships, LGEM, HWRF, COAMS, TC, and HMON. Again, this is evaluated when RI is either observed or forecast for 2020. And so for the consensus, you can see the baseline there is the dashed black line. The consensus errors is the solid red line. And it was a very, very good year for forecasting RI. Through this consensus, the errors hovered around 20 knots, well below the baseline, fading as you get to days 4 and 5 when the number of cases dropped down. And we had 73 cases. Now, again, this is not RI cases because this includes the times when it was forecast as well. Next slide, please. So looking at the individual models, here's the HWRF. It did reasonably well through about 60 hours and was pretty much a wash relative to our baseline beyond 3 days. Next slide, please. And now we've got COAMS TC. Was kind of a wash against the baseline, did a little better at 48, but at other time periods, it was pretty close to the baseline, or at the far times, not as good as the baseline. Next slide, please. HMON, right on the baseline early, did a little bit better, around 72 hours, and through 4 days, 4.5 days as well. Next slide, please. And this was a little bit surprising. This is Decay Ships. Wouldn't necessarily expect it to do particularly well for RI, but it did do very well, beating the baseline through 72 hours, but not very good at all after that. And the next slide, please. LGEM really didn't contribute positively. I actually haven't looked to see what its impact on the consensus was, but certainly taken by itself, it was not beating the baseline and was well below that at the longer lead times. Next slide, please. So this just shows the 3 years since we established the baseline. 2018 in the yellowish color was a good year. 2019 in red, not so much. It was not better than the baseline. And then 2020, the preliminary results, actually much better than the baseline. So we've had 2 good years and 1 not so good year. I think part of the message here is that I think you can expect the results to bounce around a little bit from season to season. These are not large samples of cases, even when you combine the 2 basins. Next slide, please. So here's a homogeneous comparison of the various models. This is just for the Atlantic. The consensus is the dashed orange line, and the official forecast is the black line. And the interesting thing here is that the official forecast outperformed all the guidance, including the consensus, all the way out through 4 days. That was very nice to see. And one might ask, well, how did the forecasters manage to beat the deterministic guidance? And perhaps the answer is it was the probabilistic guidance that played a role in this success by the NHC forecasters. Next slide, please. So we have some probabilistic RI models as well. There's the SHIPS RII, which has been around for a number of years. There are several formulations of that. The results that I'll show here, and these were all done by Matt, will be the consensus formulation of the SHIPS RII. There's also DTOPS, which takes the sort of indirect approach of looking at deterministic model forecasts and then attempting to get a probabilistic forecast of RI from that. And then there's the Kelly-Ripa model that I don't know anything about, actually. Again, there are a couple of formulations of it, and we'll show the consensus result of that. Next slide, please. So here we're looking now at Breyer skill scores because we're evaluating probabilistic models. The text is a little bit small, even for me, but there are a number of 24-hour formulations there, the second, third, and fourth, and fifth groupings for various definitions of RI, 25 knots, 30 knots, 35, and 40. And the longest time period shown on this slide is actually 72 hours, 65 knots and 72 hours. The zero skill represents the climatology. So we're looking at skill relative to the climatology, which I think is about 6% for the 30 knots in 24 hours version of this. And you can see that these forecasts were mostly skillful, not exceedingly skillful. The numbers only get up to about 20 or 30. Also, overall, it looks like the ship's RII, the consensus formulation of that was the most consistently skillful of the three techniques. As you get out to 36 and 48 hours, you didn't have as much success with the DTOPS or the RIPA version of that. But these forecasts were by and large skillful. That was the Atlantic. The next slide shows the Pacific. There weren't enough RIPA forecasts to go in here, but you can see some really skillful forecasts. Breyer skill score is up around 50 for both the ship's RII and the DTOPS. So they both did very, very well there. Next slide, please. Now, this is a reliability diagram. Pretty much, I think you can ignore the right 2/3 of that diagram because there are very, very few forecasts. But if you look at the 5 to 10 to 20 to 30 or 40% part of it, I think you can see, if you're a little bit imaginative, that there is some increase reliability as you go from the lower forecast to sort of the low to mid-range forecast, indicating that there does appear to be some information in the numerical value of these probabilistic forecasts. That's in the Atlantic. The next slide, I think, is the Pacific. And again, ignore the right-hand side, very, very few forecasts of very high numbers. But again, there is a nice increase as you go up from 10 to 20 to 30 to 40, even to 50% forecast, showing what to my eye looks like some decent reliability there. Next slide, please. So the bottom line is, I think that after 3 years since we formulated the baseline, I at least am cautiously optimistic that the RI guidance has indeed improved relative to the establishment of the baseline. It was also very nice to see the forecasters beat the deterministic guidance, even in the consensus sense. And that may well be because we're getting some skillful guidance that the forecasters are using. And that probably contributed to the strong OFCL results. And that is my last slide.
Well, thank you, James. One question that I have for you, does it make any sense to, and maybe you showed this and I missed it, to combine the 3 years to show that on overall over the 3 years, yes, we have improved? And,
yeah, it should, yes, except it's kind of a pain in the butt for me to combine the basins, and Mark kept making me redo the calculations every time we got another storm with more RI, and so I ran out of energy to do that particular diagram. But
okay.
In the column that follows, I could put that together for you.
Okay, thanks. Yeah, that might be an interesting slide. There is a lot of discussion on the chat, although I think most of it is an extension of previous talks. Jason Sipple had one question, one comment about, I think whether Dorian was the reason for 2019 being much or having a poorer outcome. And as you might say, I guess we still have to count it. It's still part of our database, but maybe that, because that was so extreme, he said that might have had a big negative bias for the forecasting.
Yeah, I guess my point was there's a big difference between 140 knot, or 135 or so, and 160, right? That's a massive difference, and it was there for such a long time. You don't ever forecast 160. So.
Yeah, I don't remember which storms that's so many storms. Excuse me. I don't recall.
Okay. So I'm trying to work my way through the comments, and here's one from Stan to James at the end. Is it possible longer lead time are better since method might not predict timing well, but is seeing that RI will happen? So again, that's sort of the accumulated period I think Mike talked about. So you go ahead.
I mean, so these are not, none of this is accumulated. So you're just looking at the forecast error at the particular time in question. So I guess I'm not sure I understand the question.
Okay, maybe I misinterpreted it. Stan's on the line. He could.
Yeah, let me explain that. It's just the idea that if the storm eventually is going to get to 120 knots, the 72-hour forecast doesn't care if that happened at 24, 36, 48, whatever. It just catches it. Yeah, by 72, it got there, even though the model, the shorter lead times might have said it was going to get there 24 hours, if that makes sense.
Yeah, so what's the question?
Well, the question is it possible that's why the longer lead times are showing a little bit better skill? Because even though it wasn't able to guess when the RI was going to occur, it caught that it was going to happen. And therefore, the longer you go out, well, yeah, we caught the RI, and the storm did get much stronger.
Yeah, I'm not sure which diagrams support the notion that the skill was better at the longer lead times. That certainly wasn't true for the deterministic models.
Okay, I thought you made a comment about that the longer lead times were a little better. Maybe I misunderstood that, trying to understand the different figures. Sorry about that.
Okay, well, you can follow up if you guys need to, if Stan, you need more. We do have a minute or two more before we move to the next talk. Just looking, there's so much discussion here. If anybody wants to open their mic and ask a question of James, that might be the best way to go for the next one. Okay, with no more questions coming in that I can see or hear, James, thank you again.
Sure.
And we'll move to the fourth talk of this first part of our session. This is titled Operational Applications, including ensemble products. This again is a combination of three: Brian Zachry, James Franklin, Mark Demaria. And I don't know, Brian, are you the one giving the talk?
Yes, I am.
Okay, go ahead.
Okay, thanks. Hey, Paul, would you mind refreshing this real quick? I made one update, if you can. Thank you. And yeah, thanks to Mark and James for their input on this presentation. So yeah, start off, good afternoon, everyone. It's definitely a pleasure to talk with you today regarding the operational applications. I will take more of a high-level view and focus on really some of the key projects that were supported by STI and HFIP, and also the staff contributing these projects for FY20, and then where we're going to head in FY21. We're going to have a few presentations after the break from NHC staff that will focus on some other initiatives. One of them will be really the transition into AWIPS 2 and infrastructure plans for NHC. Another will be on post-processing, verification, and other supported activities. And last, we'll be diving a little bit deeper into the storm surge modeling improvements at the NHC. Next slide, please. It's definitely appropriate to begin the presentation by providing the key projects that we support in FY20. So I'll mention all of these here, and And then in the subsequent slides, I'll talk about some of the key outcomes from each of these efforts. Some of these were mentioned already, but I'll highlight some of the key aspects here and move through these relatively quickly. The first project that we have encompasses the statistical post-processing improvements. This is modernizing the code and extending the TC guidance from 5 days to 7 days for the wind speed probabilities, SHIPs, and LGEM. This is already mentioned, including the rapid intensification and the new neural net intensity model being developed. The second main project is AWIPS and ATCF developments and improvements for forecasters. Project 3 looks at developing and improving graphical products for external users. 4 is focusing on storm surge improvements. This is in both P-Surge and also some modeling capabilities that are being done. And then the 5th project that encompasses both the joint hurricane testbed activities and R2O. Next slide, please. So we had a lot of staff contributing to HFIP and supporting us. If I forgot anybody, I apologize. It's a pretty comprehensive list of the NHC federal staff, including almost all the technology and science branch at NHC. And also the storm surge unit is encompassed under that too, led by Jamie Roan. As far as non-federal staff, I'll highlight a few here. Taylor is in the storm surge unit. Ben Tramey took over for Andy Penny for the HFIP diagnostics position. We have James, who just presented on verification. We have Jerry working on sort of product development and support. And then Kate's model and product upgrades and guidance suite support. And then Alan Brammer is the JHT R2O facilitator and also helps with various activities. Additional staff, we have Buck Sampson, ATCF, Tom LaFave helps with AWIP support, and then Pablo Santos always steps in when he can to help out, especially on the AWIP side of things. Next slide, please. So now kind of get into the projects that we've talked about and focus on some of the key initiatives that were taken. First, set here under the statistical post-process improvements, there have been substantial improvements and modifications to the wind speed probability model. One of the enhancements was regard to the wind radii. And then in the new version, the mean radii are scaled to match the OFCL forecast. And an example is shown here for Hurricane Dorian. On the left, this is the operational version in 2019. You can see in Central and South Florida and really throughout Florida, the probability of hurricane force winds was pretty high. And this was due to how the wind radii are being incorporated into the wind speed probability model. And so in the middle figure, this is a 2020 parallel version of the wind speed probability model. And here, this is more realistic of actually what happened and where the probabilities of hurricane force winds were dramatically reduced over Florida due to incorporating the OFCL wind radii. A couple of other updates: updated track and intensity air distribution, 2015 to 2019, updated land table. And again, this ran in parallel for the 2020 season. There are some still modifications that need to be done to really get this running more operational, and that'll be done in the off season. Next slide, please. Also into this category, we're looking into developing machine learning methods for NHC statistical post-processing. This was discussed a little bit in the chat by Mark Demaria. One of the pilot projects is the rapid intensification using lightning input, and then the neural network intensity consensus model, which you can see some of the skill diagram there on the right, showing both skill both in the Atlantic and also a bit in the East Pacific. So there is some promise with this method. One thing I want to highlight here is the bottom bullet is implementing in-house Python AI toolkits to facilitate R2O. R2O for AI and machine learning is quite difficult for two reasons. One is the code is it's usually quite complicated and can require computer resources. So that makes it difficult to actually transition into operations. And secondly, the grants process itself, you can't just hand over code and then run it in operations. So there is a need to develop, in-house infrastructure for AI and machine learning processing to really facilitate R2O. So hopeful that this project will actually facilitate R2O a bit better when it comes to these projects. Next slide, please. All right, so this is the project we're working on. This is project 2 for the AWIPS ATCF product improvements. Here, I think this was already shown by Frank initially, a different example of this, but we're continuing to develop and test the wind hazard recommender tool in AWIPS 2, which is obviously based off the wind speed probability model. The tool is aimed to really help forecasters with watch warning decision making and really to ensure consistent products across multiple WFOs to make sure everything is consistent when the watches and warnings are placed. This is an image for Hurricane Isaias. This is just one example. On the left is the recommender or the probability-based guidance, and on the right is the actual watch warning issued by the Weather Forecast Office. This is one example, but you can see at first glance the general area that we have watches and warnings, whatever it may be, is pretty consistent between the two. But if you look at the tropical storm warning, the red on the right figure, the recommender has this in pink, which is more of it's recommending a watch for this area. So you can see how it could refine the watch warnings. And on the left, the probability-based guidance was actually more like reality when Isaias came through. Again, this is just one example, but we're actually going to test this much more with a Facets hazardous weather testbed experiment in spring 2021, where we're going to work with multiple WFOs, multiple advisories to really kind of hash out this product and get to WFOs testing it. Next slide, please. Also, some updates for ATCF this season for 2020, as shown here. Upgraded to RHEL 7, which is nice because it allowed for virtual machine version to also be available. Added in the 60-hour point on the text output. All this allowed for enhanced backup capabilities for WPC and CPHC. Gypsy values were followed our upgrade to day 6 and day 7, and then aircraft fixing identified the maximum wind for inbound and outbound at flight level for SFMR. So it's definitely some updates from the ATCF side. Next slide, please. I'm not sure if this was shown yet, but this is the time of departure graphic, and we're continuing to make progress on this for our emergency management partners. The time of departure of 34 and 50 knot winds were run in real time this season and provided to FEMA for HRVAC and the prototypes of this product. So this isn't a public-facing product. It's for our emergency management community, and we're continuing to work with them, with our partners on this to refine and get this product into HRVAC. Next slide, please. I believe this was also shown for Project 3. Additional development was made on the Be Ready By graphic, which is just a simplified version of the time of arrival product. Again, this was run in real time this season, and it was available for decision support services if needed. Not actually sure if it was used this season or not, but I guess the Be Ready By graphic was ready if we needed it.
Yeah, Brian, I think Ken said that he did use it a few times this year.
Okay, good. I was usually on the midnight shift, so I missed it, but glad to see it got some use. Next slide, please. So in regards to other products for external users, we're in the early stages of the TC intensity forecast uncertainty product. It's intended to provide a probabilistic view of intensity distribution based on the wind speed probability model. Like I said, it's in the very early stages, and development work is going to continue with this product for the next couple of years. And on the figure showing here is Hurricane Laura. And then on the right are the 1,000-member ensemble from the wind speed probability model. And at 60 hours, this was around landfall in the Panhandle. And you can see there's a wide range of distribution of intensities at landfall. But you see more on the high side, which was higher than forecast, and actually what was more towards reality. So it's really distilling this information, something that can actually be consumed by the public. And this is one of the projects we're actually hoping to get some social science help with to guide this product for our public users. Next slide, please. Jumping into the storm surge a little bit. I know Lauren and Andy are going to present on this, so I won't say too much on the storm surge side, other than there was a substantial upgrade to P-Surge version 2.8, which became operational in, I believe, September 2020. So they're getting some really nice updates to P-Surge. And then the storm surge unit is also working on American Samoa. This is a version of Slosh that incorporates a more of a parametric wave model for this region. So they're continuing these efforts and hopefully keep making progress on that front. Next slide, please. And in regards to the JHT and R2O activities, I know Gus and Stephanie have made some progress at getting HAVs and H4 forecasts into ATCF. So we have an example is shown here for Hurricane Delta. This is roughly 60 hours before landfall when NAC issued hurricane and storm surge watches. So a good effort here to get HAVs and H4 into the ATCF. Next slide. In regards to the JHT side, it's continued to be relatively successful and expanding quite a bit. Alan Brammer, as I mentioned, is the R2O facilitator. Some of his accomplishments are listed here and just the overall accomplishments of the JHT. I'll highlight a few of these. The first is Alan provides an annual presentation to HSU regarding all the projects involved in real-time demonstrations. This is important to really distill the information down for the forecasters, and the JHT is expanding. So other test beds and other funding sources have to identify a test bed for real-time demonstrations, whether it's JTTI or JPSS. So our real-time demonstrations are expanding. So it's important that this information continues to be available for our forecasters in a really clear way, which goes into point 2, is that Alan's really distilled this information down into our own internal website at NHC, to where the forecasters can access all the projects involved in real-time demonstration and then submit feedback to us so that we can evaluate these projects at the end of the season. So great efforts there by Alan. Also incorporating the FSU TCLOG from the JHT FY 17 and 19 funding period onto NAC infrastructure. So it's actually running our side as well as the FSU side. And then we're also got in the last bullet there, Ryan Torn's project into the AWIPS software. So it's nice to see some progress on that too. Next slide, please. So moving on to the FY21 and HFIP supported projects. Most of these were covered a little bit by STI group, but I'll run through these here. The projects themselves, the general, what they encompass, the names stay the same, but we're working on changes a bit. For project 1, we're really going to focus on the machine learning and get that infrastructure set up at NHC. Project 2, Dave Zelinsky is going to talk about this more, but it's the transition to AWIPS 2 for HSU. That's going to be a focus, as well as refining the wind speed recommender tool in AWIPS. For project 3, it's the tropical cyclone wind probability distribution product that I mentioned. It's in early stages now, but we want to start moving forward with that and continue moving forward with that. Project 4 is a storm surge. So P-Surge just had its upgrades. Now we're going to focus on hazard services and a polygon-based approach. There's also a JTTI funded project by Nate Harden that'll help push the storm surge unit to using hazard services. So we're looking forward to that. And then lastly, should be a lot more bullets potentially under Project 5, but one thing we want to do is evaluate the real-time performance of the 7-day Janus guidance tool. Next slide, please. So in regards to the staff for FY21, we do have a few changes that are occurring. For non-federal staff, we did lose Taylor Trogdon from the storm surge unit, who's actually going to be working on the JTTI project for storm surge at GSL. So technically we're not losing him, just as NHC staff. And on the top of the list up there, Mark Demaria, he'll be around for Q1, FYQ1, but after that, he'll be retiring at the end of the calendar year. We won't be losing him completely though. He'll be working still with HFIP and supporting us, which is fantastic. He'll be at Sierra. But definitely want to thank Mark for all of his contributions to HFIP over the years, and continue to look forward to working with him in his new role at Sierra. Next slide, please. And that should be it. Now just open it up to any questions or comments. Thank you.
Yeah, thank you, Brian. Speaking as a former forecaster, really encouraging how many promising projects are underway now. And without minimizing any of them, maybe because you showed it graphically, that wind recommender tool was potentially very exciting in terms of the amount of change that it would make for operations of the WFO and potentially for NHC too. The reduced area of the watch and the warning, if accurate, for that particular storm was pretty remarkable. And let's see, I think there might have been a comment or question or here. Yes, Frank Marks asked, he says, Brian, have any of these new products been evaluated through SBES approaches, e.g. facets, like the surge products were? I don't know if there's been enough time to do so, but if you have any thoughts on that, you can share those, Brian.
No, I'm not sure exactly which ones have gone through any SBS process. I know some of the ones may evaluate some of these projects, but definitely not as thorough as the storm surge products. And that's why we're hoping the probability TC probability distribution, could potentially have some social science work guide that. So maybe somebody else wants to chime in, Mark, or if Jen's on the line, she may want to say something.
Yeah, so Brian, this is Frank. Well, let me expand a little bit. JHT started in 2020, roughly. And so it's one of the longest running test beds in NOAA. And so before all the social behavioral science stuff came along and facets and all this stuff, we really didn't think about it. We were trying to develop products. And so now under the HFIP strategic plan, we kind of talk about, improving probabilistic guidance, and we talk about improving communications. And so those things to me are kind of linked. And so somehow we need to figure out a way to feed off of each other on these different efforts that JHT is doing, OAR is doing, JTTI is doing. There's some way, to coordinate them a little better so they don't look so patchwork. I mean, it's great that we're doing all this stuff, but somehow we need to figure out how to integrate and work so we don't duplicate effort and we have more coherence, I guess, is what I'm pushing for.
Yeah, I totally agree. And it seems it's been really difficult to align kind of research and development with the social science work because it's hard to figure out kind of which one goes before the other. It's kind of a balancing act. So, if there's ways to improve that and kind of align product development with the SBES process, I think we'd all be happy to see that happen.
Yeah, if I could jump in here for a second, while there is some overlap, I think we should remember that the JHT started, and there's still a large component within it and some within HFIP with a focus on products for the forecaster. Whether you need social science for that, I'm not sure, but you do want the social science, of course, for the products that go out from the operational centers to the public. There might be a little bit of overlap, but they were really two different end users in that case.
Yeah, well, the thing I think about is when you first put the track cone together and how that's taken on a life of its own. It seems like anything we develop, even for ourselves, ends up getting out into the community and being used for all sorts of things that it was never intended to. So that's what I worry about.
Yeah, that didn't come out of JHT or HFIP. That came out of the Weather Service headquarters. So any other comments or questions for Brian?
Ed, I think just
maybe you'll type in through chat, or do you want to try again?
Yeah, I put it on chat.
Okay, so let's. Is it the question you have about the Ryan Torn? Can you see that, Brian?
Yeah, I'm trying to. Yep, I'm reading it now.
Okay.
Yeah, I mean, so I guess you're trying to just, look on whether or not we're going to use that in Ryan Torn's project. Yeah, I mean, we're still evaluating it, basically, but I think Mike may have some more comments on that than I do, actually.
Okay, well,
Sorry, Brian. Yeah, my phone was ringing, so I didn't hear what you said. It was about Ryan's JHT project.
Yeah, it's the final comment from Pete in there.
Yeah, I'll have to look and see what the comment actually says. Yeah, I mean, somebody will have to do the actual sensitivity, actual data denial study. So, I mean, that's something EMC would have to do. But yeah, we've been heavily using that guidance this year in targeting SONs for the G4 and radio SONs. And I think at least anecdotally, we seem to have some evidence that at least for some of those G4 flights, we saw some pretty significant changes in the track guidance once that data was assimilated, but we have to do the study to know for sure.
Yeah, the JHT doesn't have funding to do that study. That'll have to happen, outside of that, like Mike mentioned.
Okay, thanks again, Brian. Thanks, Mike, for helping out with an answer there. And we have time now to move on to the last talk of this first part of our session. And while the first 4 have been largely about NHC, and to some extent about the Central Pacific Hurricane Center too, because of the similarity or equivalence of products, we're now going to turn to the Joint Typhoon Warning Center and hear about the activity, forecast challenges, and priorities there. And Matt Kucas, if he's on the line. Matt, are you there?
I am here. Hopefully you can hear me.
Okay, yes, we can.
Okay, great. Thank you. I'll take it from here. So good morning, afternoon, and evening to everybody who's dialed in from different places in the world. Thank you for attending and listening through my part of the presentation today. I'm going to be talking about our 2020 activity and the Joint Typhoon Warning Center basins, highlight a few of our forecast challenges, and then discuss some of our development priorities and operational priorities. So next slide, please. So for this year so far, we're pretty close to normal, slightly below as far as our number of systems and number of warnings. So this is annual total to date, you'd see with 2020. So we still have a little ways to go in the Westpac Basin. We'll probably have a few more systems before the end of the year. So we're running a little slightly low number of systems and warnings, but not too far off pace overall. And I'll have a little more information about that on the next slide in more detail, if we can move on to that. So here are all of the 2020 storm season tracks. They're color-coded by intensity. And you can see activity by basin there in the Western Pacific, Southern Hemisphere, and Indian Ocean. So far in the Westpac, we had a kind of a late start this year. But we're getting close to our average number. We're at 25. The mean is 31 in a season, so we could get pretty close to that still. But ACE is fairly low compared to our mean, so we're at about 150 now. Means 274. And it seems to be related pretty strongly to the La Nina pattern we've seen this year. A lot of our development has been confined to the Western Pacific. We did get a late start to a lot of our activity, and we saw some anomalous easterly flow across the Westpac for a good bit of the season up through well into maybe even September. Then October, we got some transition. We've had multiple storms since then. So a little less room for the storms to move across the Pacific and intensify. And that likely accounts for that lower ACE that we're seeing this year in that basin. And then in the Indian Ocean, we've had just 2 systems, but both got pretty intense before they made landfall. So our ACE numbers are close, but only 2 compared to an average of 5. And then the Southern Hemisphere season, which extended from summer of 2019 into summer 2020, that's already completed. But we had 27 TCs in Southern Hemisphere, which is right on the mean. a little bit weaker than average with the ACE a bit lower there. So overall, we're looking at a pretty average storm year as far as activity, a little weak, and some pretty pronounced impacts as far as development region in the Westpac. One other feature that was interesting in the Westpac this year, we had 2 typhoons that made landfall in South Korea, which is a very rare occurrence. Next slide, please. Here's a look at our timeline. So each of the bars here represents an individual storm, and moving from left to right, that's moving through time from the 1st of January to the end of the year. So you can see a pretty regular pace, one storm after another in the Southern Hemisphere and IO. And then we had a long break between April and the beginning of July, where we just had a few systems, some activity in May, but we had several weeks particularly pronounced in June, July, where we had no activity at all, which was kind of a welcome for us with our, dealing with the work disruptions with COVID and some other challenges. It was good timing for us, fortunately. But then once the period started, we've had kind of a steady pace of one storm after another in the Westpac. Is kind of typical once it finally caught up. So next slide, please. Okay, so looking at our track errors and intensity forecast errors, this year has been maybe a little easier in terms of the tracks because we've had a lot of straight runners with less area to move across, and then a few systems that moved poleward didn't really have very complicated tracks that just sort of moved straight north, especially those 2 that moved into South Korea. So they're not particularly difficult forecast this year. So we've had, some success you can see in the stats as far as the 4 and 5 day errors in particular, approaching our 2009 PACOM goals, which are 150 nautical miles at day 5 and 100 at day 4. And right now we're looking at about 165 and 140 for day 5 and day 4 respectively for this year. So as far as trends, you can see pretty slow but steady progress over the years, maybe a little bit of flatlining, kind of what John was mentioning that they're seeing at NHC in terms of progress. I'm not sure if we scaled this in terms of percentage improvement, if it would look a little different, but maybe try that at some point. Next slide, please. In skill space, we see gradual, slow but steady improvement in pretty much all of the towels for track skill. We had a big dip in our extended forecast accuracy in 2008, which I thought was interesting in this plot and haven't had a chance to dive into. Same thing happened with intensity that year, but that's a whole nother story. But the overall story here is continued increasing skill in track forecasting. Next slide, please. Intensity errors. So we saw a decrease in most towels relative to at least 2019. Slower but less marked, or steady but less marked improvement in intensity forecasting overall relative to track forecasting. But we are seeing some improvements. Next slide, please. And in skill space, you can see increasing skill and intensity forecasts, particularly pronounced since 2014. Continuing through this year, we do see a dip in the extended towels at 96 and 120, below the 0 line on our 120-hour forecast, in fact. And in this case, the ST5D, our climatological baseline, was indicating that this was an easier to forecast year with lower errors in climatology. So that partially explains the dip. But also our errors, at least at day 5, were about 2 knots higher at the Tau 150 compared to 2019. So we'll see at the end of the season. Can't make any definitive conclusions on why that happened quite yet. We'll see at the end of the season if that holds up with the next few systems. Next slide, please. Just really quickly here to highlight all the activity at our satellite operations desk. So far in the 2020 season, all basins combined, our satellite analysts have put together nearly 6,000 fixes on geostationary and microwave sensor platforms across our area of responsibility. Next slide, please. So just a couple of forecasting challenges this year that I wanted to highlight. There were more than this, but I tried to find some commonalities and some things that were interesting. So start with track. We had 2 cases, Typhoon 14 Whiskey and Typhoon 16 Whiskey, systems that were approaching Honshu and assets in the Tokyo area. And the models, for the most part, were forecasting in both cases that the systems would become extratropical, accelerate, join the mid-latitude flow pattern, and cross that high asset concentration area around Tokyo. In the first case here on the left, Typhoon 16 Whiskey, instead of following that track and accelerating out, the system actually followed the steering ridge and turned to the south and then dissipated rather than becoming extratropical. And in the case of 14 Whiskey, the system didn't join the mid-latitude flow pattern, sort of stayed separated when we thought it would. And it took a jog for about a day and a half, 2 days to the east, and then made a turn to the north and finally became extratropical after that point. But it was interesting that there were 2 cases in the same region where we saw this rightward turn and refusal of 2 systems to kind of join the mid-lat flow pattern, contrary to what the model guidance was showing. So you can see there we had some pretty high errors in our track forecasts in the extended range for both systems. Fortunately, a bit better than the consensus, at least for 16 Whiskey there at day 4 and 5. Next slide, please. Okay, and highlighting always our favorite, the rapid intensity change example. So we had Super Typhoon 22 Whiskey that reached an estimated peak intensity of 170 knots that impacted the Philippines a few weeks ago. That's preliminary data. Obviously, there could be some smoothing adjustment when we do our post-storm review on this, but it was a marked increase of about 80 knots over 24 hours from 70 to 150. And then there was rapid weakening following that after landfall and as the system moved into the South China Sea. So our forecasts, as is typical, and the model forecast as well, underestimated the rapid intensification and the weakening in most cases. But I did want to point out here, you see our forecasts on the upper right, but on the lower right, those are the forecasts, the raw, uninterpolated forecasts from the HFIP model. And although, you know, they don't all match up perfectly with the verifying best track, the trends are really good. The rate of intensification during the rapid intensification period, there were several early forecasts there that you can see they were delayed in timing, but the rate was quite close. And then after that, there were several forecasts that did really well on the rate. The timing of the peak and the magnitude of the intensity were off a bit, but overall, those are nice trends. And then the rapid weakening, HWRF did much better with that than the other guidance that we use. You can see our forecasts were slow with the weakening and a little too high during that weaker phase later on in the storm's life cycle. Most of the other guidance was a little bit higher in intensity and much slower in the weakening trend. So it's tough in these cases when the consensus, you know, most of the guidance and the consensuses that we use are telling one story, and you have a particular model that does so well. It's hard to know when to follow the one outlier that's getting everything right. But that's a challenge for us to dig into, to continue to work on, and maybe something to think about as far as forecast aid development later on. One thing I also wanted to note here, the rapid intensification prediction aids were indicating rapid intensification for 5 forecast cycles up to 55 knots in 36 hours. So they also saw this coming. Okay, next slide, please. So just real quickly to go through our research and development priorities. In order, our priorities are TC intensity change, particularly the rapid intensification and weakening events and eyewall replacement cycles, improving those at 2 to 3 day lead times. Second priority is data exploitation, and this is focused a lot on not gathering new data as much as using the data that we have available to us, all these new microwave data, forecast data, and trying to pull out information, as much information as we can from existing data sets, and to not leave anything on the table, so to speak. And then to create new visualization platforms and methods to visualize the data at the forecast desk. Third priority is to improve TC structure, specification, particularly wind radii forecasts, and to change our cone of uncertainty to something that's more dynamic and less based on static forecast errors. Fourth priority is TC track improvement, improving the deterministic forecast and probabilistic alike, and to focus on some of our large error outliers and try to use probabilistic data to identify when those are likely to occur and reduce the errors that we see with those outlier cases. And then finally, TC genesis, timing and forecasting. We want to continue to improve our probabilistic outlooks out to our 2-week threshold, because we have our 2-week outlooks that we issue now. And then our 24-hour forecast products are analysis bulletins that we put out. So we're looking at those 2 different time frames for improving the outlooks and starting to gather, track, and intensity forecast preliminary data for those systems, those pre-genesis systems. Okay, next slide, please. So here are some of the things we try to do this year. Some of these are in an R2O phase, and some are operational changes that we've made. For each of these priorities, just a few items to highlight here. For TC intensity change, this year we've incorporated the COAMPS TC ensemble. FinMock is running that for us, so that's newly operational at our desk. We've incorporated a lot of new satellite-based wind speed data, estimates, imagery from like the AMSR2, SMAP, and SAR platforms, sensors. We're considering SIMS, eyewall replacement cycle products, and their Archer position fix estimates. We're processing ECMWF wind radii, which is newly available this year with their TC vortex trackers. They're providing wind radii for the first time, both the deterministic and ensemble models. We've worked with the Australians, who were kind enough to provide us their access model data for the Access TC, Access Global model, and their Access Global ensemble. So we're integrating those into our operations in ATCF. Working with the 16th Weather Squadron, who are developing ensemble data displays for the GEPS ensembles and are developing trackers for the GAWEM Global Ensemble, which is new this year. And as far as TC genesis and timing, we're applying S2S demo project data provided by NRL and Navy ESPC forecasts for our 2-week outlooks, and collaborations with the Climate Prediction Center and the 14th Weather Squadron, who produce the global tropics hazards and week 3 outlooks, respectively. And we collaborate with each of those organizations weekly via telephone conferences. And we're also assessing the weighted analog technique for pre-formation intensity forecasting. That's a JHT project, or previous JHT project that's continuing forward as an R2O project at JTWC, and collaboration with the PIs there. So a lot of R2O type work happening, and a lot of collaborations with outside agencies this year, and that's been accelerated with the new tools like Microsoft Teams and other platforms that we've been using. Kind of forced into it like everyone else with the pandemic, but we've had good opportunities and a lot of help and assistance and great collaboration with outside entities to make some progress. So that's all I have, the update from JTWC, and happy to take questions.
Matt, thank you very much for joining us and providing that information. Certainly there's some similarities, some overlap in the challenges and priorities that you mentioned, rapid intensification, of course. You also mentioned a couple that weren't raised by NHC, at least not this time, that you experienced. One was the interactions with the mid-level, or sorry, the mid-latitude flow. And the second was the data exploitation. Probably quite understandable given that you don't have, for example, reconnaissance or research aircraft out there, and the need to maximize, in particular, the satellite applications. While I look for any questions, maybe if you have any comments on that, feel free. I did see something from Pete here. Question is, why does there appear to be a lag in peaks and troughs between yearly total storms and 5-year running mean? Looks like autoregressive running mean used rather than a centered average. I don't know if Pete can clarify if necessary, if he's back on, or whether he's having that problem with the echoing.
Let me see. No, I still have the problem.
No, we still have multiple Petes, repeats. So I don't know, Matt, if you followed the question better than I did, maybe if you did, please feel free to answer.
Yeah, I'll probably have to look back at the data there, but I'll be happy to address that with Pete, maybe separately. I can follow up with him.
Okay. All right, great. There are a couple others here. We're getting towards the break. Let's finish up with these. One was from Frank asking, what is the best structure guidance at JTWC? And one from Scott asking, how good is the wind radii model prediction now? So structure guidance and wind radii model related questions.
Yeah, I think I can kind of put those two together, just assuming that the structure is referring to wind radii, or at least
that was
partially.
My first guess. Yeah.
So the forecasters were, for the most part, using the wind radii consensus, or RVCN. It's a consensus of several different models, one statistical dynamical, and several global model wind radii forecasts. And for the most part, in most cases, the forecasters are using that guidance, just straight RVCN for a lot of their forecasts, except in storm state change situations like extratropical transition, or if we're near thresholds for different wind radii, like if the intensity is going to be around 34 knots, if it is now or in the forecast, or expected to pass through a threshold, you can get some aberrations in the wind radii guidance, because certain models, if they're weaker than say 34 knots, they won't produce the radii. So you get some strange things in your consensus when you build those. So in those cases, forecasters will use subjective adjustment and use the DRCL, the Clipper guidance, the climatology and persistence guidance, to kind of make adjustments on the consensus. But for the most part, it's that consensus of the dynamical model, global dynamical model, wind radii forecasts, and statistical dynamical that the forecasters are using in most of their forecasts. And it is the most skillful.
So Matt, the reason I asked that question is a lot of the regional model guidance is now both COAMPS TC, HWRF, HMON are producing radii. And I wanted to know if you guys are evaluating that, because I could easily see a consensus coming out of those regional models that you might find useful.
Yeah, that's a really good point and good question. And we are yes, collecting all those data in ATCF and evaluating those. And they're part of the annual evaluation for all of our 3 consensuses. Usually the lead on that is NRL and Buck Sampson. We do some of our own evaluating at JTWC too. After they do their annual evaluation, we talk through things and decide what we're going to implement. But all those data, yeah, we are collecting those, and that is a possibility that could be included in the future.
This is Ed again. We've run out of time for this session, but this is the end of the first part. First part of the session. And as is shown on the screen, we're going to resume at 10 after the hour. But given that we are in the break time, if Matt wants to stay on, there are a couple other questions that have been asked, which we could continue with. One, Eric Blake has asked if you noticed any drop off with ECMWF performance in 2020 versus 2019. And I think there's one more question after that.
Yeah, that's a good question about the ECMWF. I was actually surprised to see that in the NHC discussion. So I'll need to take a closer look. I didn't notice that in our basins, but I'll take a closer look at the statistics and see if there are at least any cases where we see the same trend.
Okay, thank you. One last one then before we all head for our break from James Doyle. Matt, can you comment on how you use the new COAMS TC ensemble? Are the probabilistic products useful? So from Jim.
Yeah, so we're just getting used to those, using those at the forecast desk. Yeah, we're still sort of in a get used to an evaluation phase. We're gathering the trackers and making our own consensus in ATCF out of those and evaluating that from on the deterministic side for potential incorporation into the intensity consensus at some point. And then as far as the probabilistic side of it, all of the plotting routines that were developed at NRL, we do have those running now at JTWC, and they're available to the forecasters. So they are viewing regularly the track and intensity probabilistic stuff. So I would say the most interesting of those products, and I think that we've gotten most interest that's generated so far is the some of the probabilistic intensity guidance, where we can see sort of trends in terms of like timing to expect timing and degree of intensity change that you can pull out of the probabilistic data. That's really difficult to pull out deterministic model forecasts, because when you're just looking at 5 or 6 deterministic forecasts, it's just a couple lines that never really move in the same direction. So you don't get a really great sense of when and how, not even rapid intensification or rapid weakening, but just intensification or weakening in general, at what points they're going to really start to happen. And with the COAMS TC products and the plots that come with them, we're able to get a much better sense of timing and the type of intensity trend with more specificity, that we can get from the deterministic products. Sort of hard to explain that, but I hope that makes sense, what I said there.
Okay, well, maybe you and Jim can engage in more conversation afterwards. But thank you for addressing the questions, and thanks to everyone who provided input, comments, and questions. I think what we'll do now is take the break that was scheduled and resume at 10 after the hour. And let's see if there are any last minute thoughts from the HFIP administration. Is there anything else we need to know before we head to the break? Okay, so we'll see everybody back at 10 after the hour. Thanks.